Hello, and welcome to Module 8.1c, Multiplication Properties of Exponents, the power rule. Our objective for today is that I can find the power of a power, and I can find the power of a product. So let's start by defining what is this power rule. To find the power of a power, you are going to multiply the exponents. So our example is a to the mth power to the p power. And we're going to just multiply m times p. Because what we're seeing here is this is telling us how many times this entire piece gets multiplied. So let's look at it with our first example here. We've got 5 to the fourth to the second power. So if we were to rewrite this, right, being to the second power, it means this part is repeated twice. So we have 5 to the fourth, 5 to the fourth. Okay, and if we did expanded form, we would have 4 5s times 4 5s, and we have a grand total of 5 to the 8th power. Right, so this is, if you remember back to when we were doing counting atoms in science class, this is where, when we're distributing that, the subscript that's on the outside of the parentheses, it's the exact same concept. We're distributing that 2 to everything that's inside of our parentheses. So m to the third to the 5th power. Okay. Again, if we were to do this in expanded form, we have 5 m to the thirds. So it'd be m to the third, m to the third, m to the third, m to the third, m to the third. Now, we add them all up, right? 3 plus 3 plus 3 plus 3 plus 3 is 15. And we get m to the 15th power. Okay. Remember, multiplication is just a shorter way of doing addition. It's repeated addition. So we're saying we're adding 3 5 times. 3 times 5 is 15. All right, let's actually go back one, and let's finish simplifying letter A here. So we have 5 to the 8th power. Go ahead and type that into your calculator, and you're going to get the simplified value is 390,625. So 390,625. All right, let's stop down or skip down to letter C. We're going to distribute. So we'll just show this one the way that we are taught with the rule. We have y to the 1/4 times 1/2. 1/4 times 1/2. When we multiply fractions, we multiply the numerator straight across. So 1 times 1 is 1. We multiply the denominator straight across. 4 times 2 is 8. So this is y to the 1/8 power. All right, there are 3 you try problems. Go ahead and do those 3 on your own and check your work against mine. All right, so our first one, we've got x to the 4th to the 4th. So we do x to the 4th times 4, and we get that x is to the 16th power, because we've got 4 groups of 4 for a total of 16. Letter E, we're going to do p, and it's to the 2/3 power times 3/1. Again, we multiply when we deal with fractions. We multiply the numerator straight across. 2 times 3 is 3, or 2 times 3 is 6, and 3 times 1 is 3, and 6 divided by 3 is going to simplify to p squared. All right, and letter F. We have z to the 3/2 times, or to the 1/3 power. So we start with our multiplication. We have 3/2, and we're multiplying it by 1/3. And we know the 3 and the 3 cancel out. And we end up with z to the 1/2 power. And when we start talking about radicals in the second half of this unit, we will go into a little bit more detail on the rationale and the explanation and how all of that works. But right now, we just need to worry about multiplying these fractions together. All right, so Simplifying an expression with powers. When raising a product to a power, raise each factor to the power and then multiply. So when we look at this, we are looking at a couple different things happening, right? So we've got x to the third times the quantity x to the fifth to the fourth power. So that 4 is only distributing to what's inside of the parentheses. Okay, so it only distributes to what's inside the parentheses. When we do this, we have x to the third power, we have x to the 5 times 4 power. All right, so let's simplify that. X to the third power, and we have x to the 20th power, and we have a total, we have an x to the 23rd power. Right? So you just go one term, term by term, you multiply, you distribute, you combine as appropriate. So you're going to see we're starting to build in all of the rules that we've been talking about up until now. We're starting to kind of piece them all together. So when here we've got y to the third times y to the or y squared to the third power times y to the negative second. So we start off, we have y to the third. Okay, we've got a y, 2 times 3 is 6, y to the sixth, and we've got y to the negative second power. So now we go ahead, we combine all of these, they have the same base, so we can add our exponents using the product rule. So 6 plus 3 is 9, plus negative 2 is 7. So it's y to the seventh power. Okay, letter C. Now we've got the 10 being distributed. So we're going to have c to the 30th over 5 and c to the third power. And 30 divided by 5, that's going to be c to the sixth power, c to the third power. And when we combine those, since they have the same base, we can add them. It is c to the ninth power. All right, I want you guys to do letters D, E, and F on your own and then check your work against mine. Letter D, we start off with distributing. Negative 6 times negative 1/3. We get n to the 6/3, and we have n to the 5/6. Okay, now I want to get these into being the same denominators that I can add them together. So I'm going to have to take 6/3 and make that into something out of 6. So it's going to be n, right? We multiply by 2 over 2, so it'll be 12/6, n to the 5/6. And then they have the same base. We add the two exponents together. 12 plus 5 is 17/6. I don't want you writing it as a mixed number. I want you leaving it as the improper fraction on this one. Letter E, we have y squared to the sixth power times y squared. So we start by distributing. Y to the 12th power, y squared. And then we have the same base. 12 plus 2 is 14, so it ends up being y to the 14th power. Letter F. Again, we start off with distribution, right? We're going to multiply 1/3 times 9, and we get x to the third power times x squared. Same base, we add the exponents, we get x to the fifth power. Okay. We're going to go on to the next page, and we have raising a number in scientific notation to a power. So the expression 1/2 mv squared gives the kinetic energy measured in joules, this is our units, of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of the Voyager 1 probe if it has a mass of 7.219 times 10 to the second kilograms and a velocity of 1.726 times 10 to the fourth meters per second. All right, so let's break this down. We start off with 1/2, and I always like, I'm going to just use 0.5 as 1/2, right? Instead of using the fraction, I'm going to use the decimal. Times our mass, which is 7.219 times 10 to the second power, times our speed, 1.726 times 10 to the fourth power squared. Okay, and now you're going to use a calculator to do this work. And what you're going to get when you multiply all of these numbers together. So if we were to rearrange this, right, we're going to do 0.5. We're going to have 0.5 times 7.219 times 1.726 times 10, and that's going to be squared, times 10 squared times 10 to the fourth, or sorry, times 10 to the eighth, right? Because that 2 gets distributed there and it gets distributed there. Okay? So when we multiply all this together, we get 10.75 times 10 to the 10th power. Is that in scientific notation? The answer is no. So we need to move that decimal point one step to the left, and we're going to get 1.075 times 10 to the 11th power. And our unit is joules, or you could abbreviate it with just a capital J. So that is the kinetic energy of the Voyager 1 probe, which is currently outside of the solar system. Well, it's in the solar system, but it's outside of the heliosphere, which is the region in our solar system where our sun's energetic particles are pushing out, and it's now into interstellar space. And what is kind of really cool is it has this image on it, which is, this is on a golden record. There are voices that are recorded on it. There's music, there's languages, there are clues to where we are. So that little star-shaped thing in the bottom corner there, that is representing where we are in the universe with respect to various major landmarks, so to speak, in space. We've got the hydrogen bond in the bottom right there with the 1 and 1 with the bond next to it. So it's a lot of things to show who humanity is in case some other civilization were to ever come across the Voyager probe. And there are actually 2 Voyager probes, Voyager 1 and Voyager 2, that were both launched in the 1970s and are still transmitting data back to Earth today, which is a pretty incredible thing. All right, our second problem is you try. We've got the expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass m kilograms traveling at a speed of v meters per second. What is the kinetic energy of a SR-71 Blackbird if it has a maximum mass of 7.711 times 10 to the fourth kilograms and a maximum velocity of 9.84 times 10 to the second meters per second? So you do read that correctly. It can travel 984 meters in 1 second. So it is almost an entire kilometer in 1 second at its maximum speed. So that is pretty incredibly fast. So we're going to set this up. We have 1/2 times our mass, 7.711 times 10 to the fourth, times our velocity. We've got 9.84 times 10 to the second power, and that's being squared because velocity is being squared. All right, now we go ahead and we do the multiplication on this, and when you do that, you're going to get 373.3 times 10 to the 8th power. 373.3 is not in scientific notation, so we do need to move that decimal point. And so it's going to be 3.733 times 10 to the 10th power joules. All right. Example number 4 here is the power of a product. When we are raising a product to a power, you raise each factor to the power and multiply. So this is kind of what we were doing on the previous one, where we were starting to distribute to the numerical part of the scientific notation. So we start with, you need to remember that that 5 has an exponent of 1 on it, right? Anything that doesn't have the exponent written is a power of 1. So that 5 has a power of 1, and the x to the third power is there. So this 2 is being distributed to everything on the inside, just like when we did with chemistry and counting atoms. So we end up with 5 to the second power, and we have x to the 6th power. Okay, right? Because that's 3 times 2. So now when we simplify, 5 squared is 25, x to the 6th power. If I haven't said it already, I really strongly encourage you to memorize your perfect squares between 1 and 15. That will help you as you do some math later on as we go. All right, letter B. We need to distribute again. We've got that 7 out in front there. So it's, if we just remember, this is 7 times to the first times third, m to the 9 times 3, right? So that's just showing the process of what we're doing to get there. So we have 7 to the third power, m to the 27th power, and then when we actually do 7 to the third power, 7 times 7 times 7, we're going to get 343 m to the 27th power. All right, letter C. Again, we start off with, we're distributing 1/2. So we have x, and we've got 4 over 1 times 1 over 2, y to the 6 over 1 times 1 over 2. And when we go ahead and multiply those, 4 times 1/2 is 2. And y is going to be 6 times 1/2 is 3. So it's x squared, y cubed. All right, there are 3 you-try problems at the bottom of the page here, and I'd like you to do those on your own, and then we will go over them as a group. All right, letter D. Remember, 4 has a coefficient or an exponent of 1 on it, so we distribute our exponent on the outside to everything on the inside. So we get 4 to the third power, n to the 3/2 power. And when we simplify, 4 to the third power, 4 times 4 is 16, times 4 is 64, n to the 3/2. All right. Letter E. 3 has that exponent of 1, so we're distributing that 2 to everything. So we have 3 to the second power, g to the 8th power. 3 to the second power is 9, and then we have g to the 8th power. Lastly, this is a 3-term problem. So we distribute to all 3 of our variable terms on the inside, and we get x, 9 times 1/3, or 9 divided by 3 is 3. 6 to the 1/3, or times 1/3, or 6 divided by 3 is 2. Z, 3 times 1 divided by 3 is going to give us 1. Or if you just rewrote it, or if you just wrote it as x to the third, y squared, z, without putting the 1 as the exponent, that is also correct. You do not need, so the exponent, putting an exponent of 1, you never need to do that. It is unnecessary. It's implied. However, I will not be marking you wrong if you include it. All right, so next up, we're going to simplify expressions with products. So you first simplify products raised to a power, and then you simplify powers that have the same base. All right, so that's going to carry us on to the next page here, where we have got letter A. And so we've got two sets of parentheses, both that have exponents on them. So we're going to be distributing those to what they are attached to. So the 4 distributes to the 3 and to the c to the 5 halves. And the 3 only distributes to the c squared, right? It's only on the parentheses that it's attached to. So we start off. We have 3 to the 4th power. We have c to the 5 times 4 is 20, divided by 2 is 10th power. And then our second term, we have c to the 6th power. So now we simplify what we have. We simplify our coefficients, 3 to the 4th power. 3 times 3 times 3 times 3 is going to give us 81. And then c to the 10th, c to the 6th, that's the same base. We add our exponents, and it's 81c to the 16th power. All right, letter B. We are distributing, so you're going to get x to the 4th power. You do it to the first term. We have 3 to the 4th power times x to the 4th power times y to the 20th power, because 5 times 4 is 20. So we find our coefficient first. We do 3 to the 4th power. We found that in the previous one, and that would give us 81. And then you've got x. You've got two separate instances of the x, so that's x to the 8th power. 4 plus 4 is 8. There's only one y, so it's y to the 20th. So 81, x to the 8th, y to the 20th. All right, you guys are going to try letters C and D on your own, and then we are going to go over them as a group. Letter C. The 3 is distributing to all 3 terms in your first set of parentheses. So you're going to get 6 to the 3rd power, a to the 3rd power, b to the 3rd power. Then the 2 distributes, and we get times, we've got a 5 to the 2nd power, and an a to the 6th power. All right, group our terms together. So we have a 6 to the 3rd, we have a 5 squared, we have an a to the 3rd, an a to the 6th, and a b to the 3rd. So 6 to the 3rd is going to be 216. 5 squared is 25. We have the base of a, and it's going to be 6 plus 3 is 9. And we have a b to the 3rd power. And then lastly, we just need to multiply 216 and 25, and you get 5,400 a to the 9th, b to the 3rd. Letter D. We start by distributing. We get n to the 10 times 1/2 is 5. Then we distribute over here. We've got 4 to the 3rd power. We've got m to the 3rd power. And we have n, 2/3 times 3 is going to be to the 2nd power. So our coefficient comes out in front, and we group our variables together. We have n to the 5th, n squared, m to the 3rd, 4 to the 3rd, 4 times 4 times 4. So 4 times 4 is 16, times 4 is 64. We'll make that look more like a 4. So we have 64. We have n is our base. 5 plus 2 is 7. There's a total of 7 n's, m to the third. So 64 m, or n to the 7th, m to the third. All right, so now we've got examples of power and product when it comes to area specifically. Area we know is length times width, or volume in this case is length times width times height. So Janine is designing an early version of a game and wants to use a cube to stand in for her characters. Okay, so we're going to highlight the fact that it's a cube because that's kind of important, which the characters she'll design later. She bases the dimensions of the cube around the height of each character, which she defines as 1/8 of a pixel. 1/8 x pixels, where x is the height of the total game screen. What is the volume of the cube in terms of x? All right, so, volume is the side length. Volume of a cube is the side length cubed. And if we know that the height is 1/3 x, we know that we have 1/3 x being cubed. All right. And so when you do that, right, we have to distribute the 3 times the 1 to the 1/3, and to the x, you have 1/3, and we're going to keep the parentheses there, to the third power, x to the third power. And when you multiply 1/3 times 1/3 times 1/3, you get 1/512. Okay. All right. Sorry, that was 1/8 of the height, not 1/3, 1/8 of the height. That makes way more sense. So 1/8 of the height, 8 times 8 times 8 is 512. All right, and then you have the x to the third. All right, so that is how we go ahead and solve that one. So let's look at Sir Terry Frost's Orchard Tambourine B is a painting on a square canvas that consists of 5 rows and columns of smaller squares, each containing a circle. If the side of each smaller square is x inches and the side of the whole canvas is s inches, then what is the area of the painting in terms of x? All right, so first of all, area of a square, the area of a square is going to be equal to the side length squared, right? Well, what is the side length? We have this whole thing is s, right? This whole thing is our side length. So that times that is going to give us our area. Now, if we look at it though, one row is x. So this would be x, this is x, this is x, this is x. This is x, 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 because each one of those is a square, right? So each side, each measurement is the same. So my side length is going to be 5 x's. So when I go to look at my area, we have 5x is the length of the side, and we are squaring it. So now we distribute the 2 times the 2 to the 5 and 2 to the x. So we have 5 to the second power, x to the second power. And 5 times 5 is 25, x squared. That would be our measurement, 25x squared. All right, our U-try problem. A Rubik's Cube is solved by having all 9 squares on each side be the same color. If a side of each puzzle is 9 of the 9 squares is xy centimeters long, what is the volume of the puzzle? So let's look at our example here. If the side of each of the 9 squares is xy centimeters, so that's xy, that's xy, that's xy. What is my total side length of the side of a Rubik's Cube? Well, that's going to be 3 xy's. So if we're looking for the volume, right, volume of a cube is the side length squared. So we have the side length cubed, so we have 3xy to the third power, and now we need to apply that exponent to everything on the inside. So we have 3 to the third power, x to the third power, y to the third power. And I know I can simplify 3 to the third power. 3 times 3 times 3 is 27, x cubed, y cubed. So that's the dimension of a Rubik's Cube. And there you go. That's the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you all have a great day.